Okay, thank you students. Today I am going to teach you about the different types of operation in your discrete mathematics, different types of operations in your discrete mathematics. Okay, so let me take you and adjust the camera so that you will understand it correctly there. The first type of operation, we call it as unary operation. Unary operation, that means what? If f is a function from x to x, if f is a function from x to x, okay, then this type of function we call it as unary function, okay, or unary operation, where x is any set as we had described in the algebra, any one set you can say, okay. And the example is given as f of x equals x squared plus 1, f of x equals x squared plus 1, where for all x belongs to R. So now look at this particular function. What f does on x? What f does on x? Just whatever you are putting on x, square it and add 1. Square it and add 1. That's what the function of f here. Now look at this. This is a function from R to R. R to R. That is the domain is R, and the range set is also R. Our domain is R and codomain is also R. Such a type of function we call it as unary function or unary operation. We say unary operation. Okay, so we can say a lot of functions also. I can give you more example for this unary operation. For example, I am taking another function. Take for example here, I can take right here. Now f of x equals f of x equals from x square plus x and minus 1. Again, this is a function of the type f is from R to R, where the domain is also R and the codomain is also R, set of real numbers for all x belongs to x, for all x belongs to set of real numbers. Now this type of function we call it as unary function. Okay, now I am coming to the second one, is called binary function. Okay, so what is a binary function now? Now look at this binary. That means what? If f is a function or an operation from x cross to x, I mean, you look at this. This is what the domain is, a Cartesian product of two sets, the same set, not a different set, same set, and the image is x. The image is what? X. Okay, if an operation like that, that is an operation acting on only two elements, then we call it as the binary operation. A good example that given here is f of x comma y equals x squared plus y squared for all x comma y belongs to R. Now look at this, the function f, it is from R cross to R, that is the Cartesian product of only two elements R to R, set of real number and set of real number, and the codomain is only one element, that is what? Only one set, the set of real numbers. Such a type of function we call it as binary operation or binary function. Okay, I can give you a lot of examples for this binary operation. Take for example, if g of L comma m equal to, I can take like this, L by m minus 1 for all L comma m belongs to L comma m belongs to set of real number. Okay, So this is also a good example for what? A binary operation. So here G is a binary operation acting on the two variables L and M in this particular way, and the result or the image is a single set of real numbers. Okay, single set of real number. Such a type of function or such a type of operation, we call it as binary operation. We say binary operation. Okay, now coming to the n-nary operations, I do want to talk about the n-nary operation. Now look at this n-nary operation. Now if your function is from the n cross product of the same sets to a single set, the Cartesian product of the same set, and the image set is this particular set x, then we call it as an n-nary function. Okay, this is called what? We call it as n-nary function. Okay, so example is given like that. Good example is given: f of x1, x2, x3 dot xn, where all x1, x2, x3, xn, shortly saying xi, where I varies from 1 to n belongs to R. Then this particular function, what it does, it does this, that is, it squares all the variables and takes the square root of that. Okay, squares all the variables and take the square root of the sum of them, square root of sum of the variables. Okay, so this is what f does here. So f is an operation on these n elements, and it just f just squares all the variables and square root is taken. That is what the operation of f. That's what the function of f. Now this function f, we call it as n-nary operation. N-nary operation, because the operation is done on n elements or n variables, you can say. Okay, so like that, there are three types of operations. One is unary operation. The operation is of the form f from x to x, and then binary operation is of the form f x cross x to x, and n-nary operation of the form f where x cross x cross x cross x equals x. Okay, so these are the examples given to us. In the next class, we are going to study about the property. Unlike the unary and n-nary, the binary operation have some good properties, such as commutative, associative, and distributive. Commutative, associative, and distributive. These properties that we are going to discuss in the next class. Okay, so binary operation have this wonderful property called commutative, associative, and distributive. In the next class, we will be discussing about these properties. Till then, thank you.